In 1903, a Southern Pacific fireman climbed into his cab at the base of Donner Pass and never came back out alive. He wasn't in a wreck. There was no explosion. He suffocated, sitting still inside a 2-mile tunnel, while his own locomotive filled the cab with smoke and couldn't get enough air to clear it. It happened more than once. And the railroad's fix wasn't a better fan or a shorter tunnel. It was building an entirely new kind of locomotive, one where the crew sat at the front and the boiler, the firebox, everything that could kill them, trailed behind. 194 of these machines were built. Only one still exists, and almost nobody's ever heard of it. Here's why that needs to change. In 1903, a Southern Pacific fireman climbed into his cab at the base of Donner Pass and never came back out alive. No wreck, no explosion. He suffocated, sitting still, while his own locomotive filled the cab with smoke faster than the tunnel could clear it. It happened again and again, until Southern Pacific did something no other American railroad had ever done at scale. It built a steam locomotive backwards, crew at the front, boiler, firebox, smoke, all of it trailing behind. 194 were built this way. Today only one survives. And this is the story of why a locomotive that actually solved its problems still ended up almost completely forgotten. Here's the thing nobody tells you about the golden age of steam. It wasn't just powerful, it was dangerous for the people running it, not just the people watching it go by. Southern Pacific's transcontinental route crossed the Sierra Nevada through Donner Pass, one of the steepest, snowiest mountain crossings in American railroading. To keep the line open through brutal winters, the railroad built miles of wooden snow sheds, essentially permanent tunnels, covering the tracks to keep avalanches off the rails. That solved one problem and created a much worse one. A steam locomotive burns fuel to make heat, and heat makes smoke. Out in the open, that smoke just disappears behind you. Inside a snow shed or a real tunnel, it doesn't go anywhere, it builds. Crews working long grades through these enclosed sections were breathing concentrated smoke and gas for minutes at a time, sometimes longer if a train stalled, and trains did stall. On steep grades in thin mountain air, an overloaded train losing momentum inside a tunnel wasn't just an inconvenience, it was a slow-motion emergency. Engineers and firemen reported dizziness, blackouts, and in the worst documented cases, crew members were found unconscious or dead in the cab by the time help arrived. Southern Pacific's own operating records from the early 1900s list multiple asphyxiation incidents along the Sierra grades, not a scandal, but as a routine operational hazard the railroad had simply learned to expect. Think about that for a second. A hazard so common, it became routine paperwork. The obvious fixes didn't work. Better ventilation in the sheds helped a little. Running fewer trains through peak hours helped a little. But the fundamental problem was baked into the physics of the locomotive itself. The crew always sat directly behind the firebox, directly in the path of everything that engine was burning. Every other railroad in America with a smoke problem just lived with it. Southern Pacific didn't. And the solution they landed on was so strange, so mechanically backwards, that no other railroad in the country ever fully copied it. So here's the idea Southern Pacific's engineers landed on, and it sounds almost too simple to work. What if you just turned the locomotive around? Put the cab at the front, let the crew breathe clean air, pulled in ahead of the smoke, instead of sitting right behind it. On paper, brilliant. In practice, there was one enormous obstacle standing in the way, and it's the reason nobody else in the country had done this before. Coal-fired locomotives need a fireman constantly shoveling coal from the tender into the firebox. If you flip the locomotive around, the tender and the coal ends up at the back, completely disconnected from the firebox at the front. You physically cannot shovel coal 50, 60 feet through a boiler. The cab-forward idea should have died right there, on a drafting table, as an interesting but impossible thought experiment. Except Southern Pacific had something almost no other major American railroad had: cheap, abundant oil, right in its own backyard. California's oil boom in the early 1900s meant Southern Pacific had already been quietly converting large parts of its steam fleet to burn fuel oil instead of coal, partly for cost, partly because oil burned cleaner. And oil doesn't need to be shoveled, it flows through a pipe from a tank at the back of the locomotive all the way to a firebox at the front, no matter how far apart they are. That one detail is what made the entire cab-forward concept possible. Baldwin Locomotive Works built the first oil-burning cab-forward for Southern Pacific in 1909. Think about how specific that solution is. This design only works if you're already burning oil. Any coal-burning railroad in America hit the same asphyxiation problem and simply couldn't use this fix because their fuel doesn't flow through a pipe. Southern Pacific wasn't just solving a safety problem. It was solving a safety problem using a fuel supply advantage nobody else in the country happened to have. And once that piece clicked into place, they didn't build one or two of these things as a test. They built nearly 200 Let's actually look at what Southern Pacific built, because once you understand the mechanics, the whole design stops looking strange and starts looking almost obvious. Picture a completely standard articulated mallet locomotive, the same basic layout used on dozens of heavy freight engines across the country. Now flip the entire thing end for end. The cab, normally the very last thing at the rear, sits at the absolute front of the locomotive, ahead of everything else. Behind the cab comes the smoke box and boiler, running backward relative to the direction of travel. And behind that, coupled where you'd expect a locomotive's front pilot to be, sits the tender, the fuel and water supply, literally trailing the boiler from what looks to anyone unfamiliar with the design like the wrong end. The engineer and fireman rode in a cab that, for the very first time in American railroading, faced forward into clean, open air, with an unobstructed view down the track instead of a view dominated by a boiler barrel in front of them. Every control in that cab had to be re-engineered too. Throttle linkages, brake valves, whistle cords, all of it rerouted to work in what was, mechanically, a locomotive built as a mirror image of everything else on the railroad. And it wasn't just safer, it turned out to be better in ways nobody had specifically asked for. With no boiler blocking the crew's forward view, engineers reported dramatically improved visibility on curves, and at night, you could actually see the headlight beam and the track ahead, instead of squinting around a barrel of steel. Southern Pacific's own operating reports from the following decade credited the cab forward design with fewer visibility-related incidents across the Sierra grades, an unplanned bonus on top of solving the smoke problem it was built for. By the 1930s, Southern Pacific and Baldwin had refined the design through multiple classes, the AC-4 through AC-12 series, each one slightly larger, slightly more powerful, but keeping the same fundamental backwards layout that had started as an emergency fix for a body count nobody wanted to keep explaining. And that's when the numbers started getting genuinely impressive, because it turns out a locomotive built to save lives could also pull some of the heaviest trains on the entire Southern Pacific system. So remember what I told you at the start, that this whole thing began with a locomotive that couldn't kill its own crew anymore. That was the promise. Here's the twist nobody expects. The cab forward wasn't just a safety compromise, a slower, weaker locomotive that traded power for survival. Southern Pacific's engineering department, once they'd solved the fundamental how do you fuel a backwards locomotive problem, kept scaling the design up. The later AC-11 and AC-12 classes, built right through the early 1940s, were put in. For more than 30 years, the cab forward was simply part of daily life on Southern Pacific's mountain divisions. Crews who'd grown up hearing stories about the old asphyxiation incidents now rode in cabs with clear forward visibility and breathable air, hauling trains their predecessors couldn't have managed safely a generation earlier. Retired Southern Pacific engineers, interviewed decades later for regional rail history projects, consistently described the same thing. Riding in a cab forward through a snowshed felt almost anticlimactic after hearing the old stories. No smoke, no gasping for air, just a clear view down the track, like it should have been the whole time. The design proved flexible enough to handle far more than its original mission. Cab forwards worked heavy freight, yes, but also passenger trains, including sections of Southern Pacific's premier transcontinental services whenever the route crossed the Sierra. Diesel-electric locomotives arrived on Southern Pacific in growing numbers through the late 1940s and 1950s, and they hit the cab forward with a problem no amount of clever engineering could fix: standardization. A diesel unit built for Southern Pacific could be serviced with the exact same parts, by the exact same trained mechanics, as a diesel unit built for any other railroad in the country. A cab forward could only be serviced by people who understood a locomotive configuration that existed on precisely one railroad on Earth. Every specialized skill Sacramento's shop crews had built up over 3 decades became almost overnight a cost with no equivalent anywhere else in the industry to share it with. Southern Pacific's own retirement records show the cab forward